Welcome to the chapter 7.2 lesson video. Today we're going to be solving triangles that have the pattern of angle, side, side. Now this is something that is usually referred to as the ambiguous case. And the reason it's referred to the ambiguous case is because there is a bit of work to do in order to determine how many solutions there actually are to the problem. Sometimes there will be 0 solutions, sometimes there will be 1 solution, sometimes there will be 2 different triangles that are both solutions to this. We're still going to be using Law of Sines. It's just a little bit different now because we'll be missing an angle, so the look is a little bit different. And we're going to talk about it. I'm going to give you kind of a flow chart to follow in order to determine how many different triangle solutions there are. And I'll show you how to use it. And then during class, I'll provide it to you guys so you can print it out for yourself or download it or save it. I do suggest that for now, though, you copy it down and that's probably a good start. Okay, let's go ahead and get started. All right, so we're going to talk about the angle side triangle situation, the ambiguous case, and talk about how to solve it, and also talk about the flow chart, how to figure out how many solutions you have and how to actually get those solutions. All right, so the first thing we need to talk about here is this picture, and this picture has a lot going on at first. It's kind of weird, but here's how this works. If I have a triangle where I have an angle, a side, and then another side, a lot can be determined based on the length of that second side, the one that's across from the angle. If that side is really long, then it forces us to have a nice long triangle just like this. If it is a perfect or a particular height, we can make a triangle coming this direction or a triangle coming this direction. It will actually make 2 different triangles with the same length side. Or if it's a different height, we could have exactly 1. It could drop right down here perfectly and make a right triangle off to the side here. So that side, that opposite side, can determine a lot of things. Depending on how big it is, it can change how many different solutions there are. And so what happens is we compare it to the height of the triangle. So the height of the triangle is the adjacent side times the sine of A. That's how we calculate the height of the triangle. It's whatever this is times the sine of A. That'll be this length right here. If our opposite side is bigger than that length from here to here, then there's going to be 2 triangles. There's going to be 2 different situations where we can make a triangle. If it's perfectly equal to this, then it makes 1 triangle. It makes a right triangle. And then lastly, if our opposite side is less than the height, then what's going to happen is it would kind of come down, but it wouldn't ever be able to meet up down here with this side of the triangle. And so this is what the flow chart is going to do. It's going to help us determine which of those scenarios we have, which is going on. There are about, 6 different potential outcomes to the flow chart, and a lot of them are overlapping, but there are kind of 6 different potential outcomes. And so hopefully I'll show you how to use that flow chart. We'll do a couple practice problems and see if it all makes sense. Okay, so this slide you should have seen in the last video. We are on to the second part here where we're having a triangle with 2 sides and an angle not between them, the ASS triangle. Now in this situation, sometimes there are 2 solutions, sometimes there are 1 solution, sometimes there is no solution. This is the one called the ambiguous case. We are still going to use the law of sines here. And so we'll talk about the law of sines again and use it again. Remember, the law of sines is that thing that says the sine of A over A is equal to the sine of B over B is equal to the sine of C over C. And we can use any 2 of those to make a proportion. We're going to use that still, and it's just a little tricky because sometimes we're going to have 2 solutions, sometimes we'll have 1 solution, and that's part of the problem is figuring out how many solutions there are and then finding those solutions. So let's go ahead and get started. All right, so this is the flow chart, and yes, it is overwhelming and it is tedious. If I were you, I would take a moment right now and copy it down. I'm going to go ahead and highlight all the stuff that I think you should copy down. You should copy down this, and this, and this, and this, and this, and then this part down here, the conclusion to that branch, this, and then this part down here, the conclusion of that branch, this, this. So you don't really have to draw the pictures. You can draw the pictures if you want. I will share a copy of this a little bit later with you guys in Google Classroom, but it's probably a good idea so that way you can have it all ready and it'll help commit it to your memory so that way you know it better if you write it down yourself. But here's how this works. So the first thing you're going to do when you get one of these problems is you're going to check whether the angle is given is acute or obtuse. That's our first branch. If the triangle is acute, then you move on to these branches over here. If it's obtuse, that's kind of your best case scenario. Then what you do is you look at your opposite side and compare it to your adjacent side. So they usually give you an angle. The opposite side is the same letter, just the lower case. If the opposite side is less than the adjacent side, then it means that this picture is your result. It means that that little side isn't long enough, and so there is no triangle possible. If your opposite, when it's obtuse angle, if your opposite side is greater than the adjacent side, then it means that it's big enough, it will reach and cross over somewhere on this dashed line, so there would be one triangle. So there's your first instance of no triangle versus one triangle for obtuse angles. That's the easier branch. The acute angle branch has a few more situations. The first things first, you get an acute angle, you look, is the opposite side less than or is the opposite side greater than? If the opposite side is already greater than or equal to the adjacent side, then you know there is only one triangle possible. So that's another fairly easy branch. So they give you A, it was acute, and then little a was bigger than little a was bigger than little b, and so there is automatically just one triangle, and that is the case. All right, the other situation is if your opposite side is less than your adjacent side, then there's three potential outcomes. So what you're going to do is you're going to take the length of the opposite side. Remember, the opposite side is just the lowercase version of the letter you're given. You're going to take the opposite side and you're going to compare it to the adjacent side times the sine of the angle. In this case, the angle is A. So the adjacent side times the sine of the angle. If the opposite side is bigger, then what it means is there's kind of two potential ways that we could sneak that opposite side in. We can either make this kind of slanted triangle, or we can make the big triangle, and so we have to consider both options. If the opposite side is equal to the adjacent times the sine of A, then it's going to make this perfect right triangle situation. And then if the opposite side is less than the height of the triangle, then what it means is this little purple piece is kind of dangling here, and it'll never make it down to that dashed line to complete the triangle. So this adjacent sine of A piece, this is just that height length, right? So if we have bigger, then it's going to be able to hit twice. If it's equal, then it just comes down. It is the height. And if it's too small, if the opposite side's too small, then it means it'll never be able to reach this dashed line to complete our triangle. Okay, now I will provide this for you on quizzes and tests. At this point in time, I'm not expecting you to memorize this, but it is a little bit tricky. Without it, I would make sure I write it down, make sure I understand it well. I will go over it a bunch. I'll use it a bunch in these next 4 examples, and I expect you to be fairly familiar with it. And if at some point you realize you've kind of accidentally memorized it, that's kind of the hope. All right, let's go ahead and try a practice problem. So here's what a problem will look like, and you'll notice I included the little flow chart up here to the right so that way you can see it and reference it throughout this problem. And here is how I go about these problems. So the first thing I do is I actually start by drawing a triangle. Okay, so very similar to the other problems, I draw a triangle. If I end up not needing it, that's fine. If I end up to need to draw another one, that's fine. But I'm going to draw and label what I have. So I have big A is 57 degrees, little a is 23, and little b, which is up here, is 25. Okay, so at this point, I know that I will still need to find some other stuff. But before I can do that, I have to reference my flow chart. And so a lot of times I just write this down off to the side or something. I have the flow chart right here though, so I'll probably write it down on there and just kind of go through it as I go. So first things first, I look at my angle, 57 degrees. That is an acute angle. So that's an acute angle, so I'm on this branch over here because 57 degrees is an acute angle. All right, the next thing I'm going to do is I'm going to compare my opposite side, my opposite side is little a, with my adjacent side. My opposite side is 23, my adjacent side is 25. 23 is less than 25, so I am on this branch right here. Okay, so that means I have three potential outcomes, and I need to see what's going to happen. So I'm going to look at my opposite side still. So my opposite side is 23, and then I'm going to do 25 times the sine of the angle, sine of 57. That gives me 20.9, 20.9. So my opposite side was 23, and that is greater than my adjacent times the sine of 57, which was 25 times the sine of 57. Okay, so when I calculated it out, I got on this branch, which leads me to the conclusion that there are two possible triangles. Because of that conclusion, I'm going to now draw my picture again because I have two possible triangles. I'm not going to draw them to scale. I never worry about that. That's not necessary or really important. But I now know there are two possibilities. So I draw this again, draw this again, and I draw this again. All right, so I have two triangles. Let's fill in what's missing. So what's missing from these is big B, but we're gonna call this big B1, and we're gonna call this big B2. And then big C, we'll call this big C1, and we'll call this big C2, and little c1 and little c2. All right, so we're going to have to solve both of these triangles. We're going to start by using our law of sines to find that missing angle B1 and B2. And then we're going to just use our normal, it's pretty straightforward, triangle sum, law of sines to get the other two. We'll kind of treat them as separate problems after that point. So let's go ahead and let's start with that first piece. So I'm going to go ahead and say the sine of 57 over 23 is equal to the sine of, I don't know which one I'm going to get yet, so I'll say sine of B over 25. Okay, I go ahead, I cross multiply and divide the 23 over, so I get the sine of B is equal to 25 times the sine of 57 over 23. Okay, and this is where I'm going to need to do a little math. I'll pull my calculator out to get big B. I'm going to do the inverse sine, and I'll get big B equals the inverse sine of, and I'll plug that big old fraction into my calculator real quick. And I got 0.9116. So I plugged this big old fractiony piece in, and I got this decimal. And then I took the inverse sine of both sides. And when I take the inverse sine of that number, I get big B, let's turn the pen back on, big B is equal to 65.73 degrees. Excellent. All right, I'll just call it 65.7. That's easier, 65.7 degrees. Okay, so that's one of my angles. That's what we're going to call B1. Okay, so that's my first answer. Now to get B2, I need to remember how inverse sine works. Okay, when we take the inverse sine, it occurs in two places. It occurs in this quadrant, and it occurred in this quadrant. Okay, so because it occurs in two places, we can find our other angle pretty easily as well. To find our other angle, we're going to go ahead and do 180 minus that 65.7 degrees, and we get our other angle, big B2, to be 114.3 degrees. All right, so that's the hardest part of the problem, is finding the first two angles. From here, you can really kind of think of them as two separate problems. I will try and do the work at the same time just to save room and space here, but you can really kind of consider them as two separate problems from here on out, because they're kind of disjoint and they don't affect each other from this point on. So the next thing we're going to do is we're going to find big C1 and big C2, and that's just triangle sum. So we do 180 minus angle A minus big B1 and 2. So we do 180 minus 57 minus 114 point, oh, sorry, let's do B1 first, minus 65.7. So big C1 is equal to 57.3. Oops, I wrote that all sorts of wrong. 57.3. And then big C2, we do the same thing, but now we subtract B2. So it's 180 minus 57 minus 114.3, and we get big C2 is equal to 8.7. And these are angles, so we say degrees on both of those. All right, so there's the big angle C1 and the big angle C2. We just did the same calculation with using the two separate angle B's. So I use this one to get this one and this one to get this one. All right, and then the last thing we have to do is get little c1 and little c2. Once again, just to save space here, I'll do the work one time and with this kind of slash notation. So I'll say the sine, I gotta use law of sine, sine of 57 over 23 equals the sine of, I'm looking for little c, so I need to use big angle C1 and 2. And if I use big angle C1, it'll give me little c1. If I use big angle C2, it'll give me little c2. All right, so I'll cross multiply here, and I will get that little c1. So this is like what we did last class with little c2, so I'm not showing all my work here. This is like what we did last class. I get little c1 is about 23.1. And I get that little c2 is about 4.1. And there we go. We solved both triangles. We have all three missing pieces from both triangles. We'll definitely do this again next in our live session, and I'll help make it a little more sense because there is a lot going on here. You're basically doing the problem twice because that side, that opposite side, can kind of swing, and it can either hit at a smaller, sharper angle or at a wider, bigger angle. Okay, let's go on, move on to some easier examples. All right, so we're gonna start this problem the same way. We're gonna go ahead and we're gonna start by drawing our triangle. We don't know how many triangles do yet, so we'll just draw one. Big A equals 55 degrees. Little a equals 9. And little b equals 25. All right, and then we'll work our way through our flow chart over here. So we'll start, A is acute. All right, so we got 55 degrees. That's, I think, the same as last time. Our opposite side, A, is less than our adjacent side, B. So 9 is less than 25. So we're on this branch here. And then we'll go ahead and we'll calculate real quick. So we'll go 25 times the sine of 55. And we have A is 9 still. And 25 times the sine of 55 is 20.5. And so you'll see that 9 is definitely less than 20.5. And so that puts us on this path right here, which says then there is no triangle possible. So because we followed our flow chart, because we saw that it was acute, then we saw that our opposite was less, and then we saw that our opposite was less than the height, we know that there is no triangle possible, and so we're done. We just say no triangle. That's it for this problem. So as much as some of them can take a long time, some of them can also go really quickly. You saw this one go really, really quickly, whereas the other one took quite a long time. Let's try another example. We got 2 more. All right, so this one says, given angle C. All right, so this is feeling a little bit different. They gave us a different angle. Totally fine. Doesn't matter which angle they give us, as long as they give us an angle, the side across from it, and one of the sides next to it. Perfect. We have the right setup. We're just using angle C rather than A this time. Let's go ahead and draw our triangle. I like to always draw my triangles the same. So when I draw angle C, I'll put it down here. C equals 43 degrees. Little c is across from that, that equals 9, and little a is down at the bottom here. This is indeed angle side. Let's go ahead, our angle is acute, good. And then we look, our opposite side this time is the C, not the A. So our opposite side is 9, and our adjacent side is the 7, so we're on this branch this time. So we're acute, and then our opposite side was 9, and our adjacent side was 7, and 9 is greater than 7, so that means that, hey, there's only one triangle this time. So there is only one triangle this time, so we can solve for that one triangle. So we need to find big A, big B, and little b. And it's going to be fairly similar to the other one where there was two triangles. We just don't have to split and do the two possible solutions path. So we'll go ahead and start with the law of sine. So we'll say sine of 43 over 9 is equal to the sine of, we're going to use A because that's the side that we know something about, 7. We'll cross multiply, we'll get the sine of A is equal to 7 times the sine of 43, and I've divided that 9 back over. And then I will plug that in and take the inverse sine. So I'll take the inverse sine of, let's plug that in real quick and see what we get. So we did 7 times the sine of 43 divided by 9, and we get 0.53. That's good enough. So we'll do the inverse sine of that. And we get that our first missing angle, big A, is equal to 32.04 degrees. Approximately, there was some rounding involved, so our answers could differ slightly, but that's fine. So that's big A, so that's our first angle. To get the next piece, it's not too bad. We're just going to go ahead and use triangle sum. So for big B, we're going to go ahead and say 180 minus C minus A. So that's 180 minus 43 minus 32.04. And we get that big B is equal to 104.96 degrees. Cool, we got another piece done. All right, and our last piece is find little b. And well, we just found big B, so we can now use law of sines again. So we'll use the c's first. Sine of 43 over 9 is equal to the sine of big B we just found was 104.96 over the side across from it, which is going to be our little b. We'll cross multiply again, so we go little b equals 9 times the sine of 104.96 over the sine of 43. We divided that piece over when we cross multiplied. So we plug that into our calculator. 9 times the sine of 104.96 divided by the sine of 43, and we get that little b is equal to 12.75. There we go. We found all three missing pieces, and so we have solved the triangle. And so you'll see on this route, because it was acute and then the opposite side was greater than the adjacent side, it made the problem a little easier because we knew right away there was only one solution. Okay, one last example. All right, so we have given angle A is 115, little b is 8, and A is 11. We'll start by drawing. Once again, we just draw an ambiguous triangle. It doesn't have to commit to the shapes or acute and obtuse. We're not trying to be that accurate. Big A is 115, little a is 11, and little b is 8. Okay, let's go over to our flow chart. Hey, we have an obtuse angle right now, so we're on this branch this time. And so we're just comparing the sides, all right? So our opposite side is 11, and that is greater than our adjacent side is 8. So 11 is greater than 8, so that means we're going to have one triangle as a solution. So we can solve, this is going to be very similar to that last problem we just did. This will be oops, sorry, I labeled my picture wrong. Let me fix that. Let me move b over to this side. B equals 8. Doesn't really matter anything we did so far. But we'll put big B down here, big C and little c. And I'm actually going to change those colors because I like the two-tone color scheme. So big C, there we go. All right, so let's find these things. Pretty much the exact same problem at this point, just different numbers. So we go sine 115 over 11 equals sine of, we're going to use b because we know little b, sine of big B over 8. We'll cross multiply, we'll get sine of big B equals 8 times sine of 115 over 11. We divided that 11 over after we cross multiply. So we'll put that in our calculator. You do 8 times the sine of 115 divided by 11. You get the sine of B equals 0.659. I'll take the inverse sine of that, and I will get that my big angle B is equal to 41.23 degrees. Awesome, I know that angle now. Got to find the other missing angle, big C, triangle sum, 180 minus A minus B. So we'll plug that in our calculator, 180 minus 115 minus 41.23. We get that big angle C is 23.77 degrees. Awesome, we found big angle C. And then law of sines one more time to find little c. So we go sine of what we were given originally, 115 over 11 equals sine of 23.77 over little c, which is what we're looking for. Cross multiply, you'll get little c equals 11 times the sine of 23.77 over the sine of 115. So I just cross multiplied and divided the sine of 115 over. I'll plug that into my calculator. 11 sine 23.7 divided by the sine of 115 equals little c is 4.88. All right, with that, you should have enough information to maybe get started on the homework. We will go over this plenty of more times in class, and so if you have questions, I'll be glad to answer all of them. Until then, I hope you have a great day, and I will see you next time.